Hello YouTube viewers, welcome to my show Rocket Monday. In today's episode we're going to talk about Chandrayaan 2. So let's dive right into it. So what is Chandrayaan 2? Basically, you can guess it's basically India's second exploration mission to lunar surface. Basically, this is supposed to soft land on moon. That is a very big deal because we have already achieved lunar orbit before that, and also a Martian orbit. So we know how to go into further places and actually grab onto an orbit. So we got that. It's just this is the first time we are trying to land on something. So that's a very important thing. And this was launched in July 22, 2019. Obviously, now that was not the original date. Original date supposed to be a few days earlier, so they're supposed to launch it exactly at the time of Apollo's 50th anniversary, but due to a technical computer glitch they had to scrub the launch. So that happened, and it has three primary things. Basically, yeah, they have an orbiter, then they have the lander, and then they have the rover. These are the three things that they are carrying. So what is the project about it? So project was the idea of the project was started in August 2009 by ISRO, and at this time Roscosmonaut was also helping India to develop the rover basically. So because India has already expertise for the everything else, but they did not have expertise about making a rover. So this was the Roscosmonaut supposed to help out, but due to their failure of mission of they're supposed to land on a moon of Mars, Ganymede I'm saying Phobos. They're supposed to land on that. Mission failed, and they were using the same technology for Indian mission also, so they cancelled the project. So they are left in 2013. At that time, India made a decision: let's make completely indigenous. Let's not go and ask someone. Let's build everything in-house. So that's the project basis. Now what they're supposed to gain about it, they're like, okay, we are doing this, what are you supposed to know about this? Basically, India NASA's mission, they had figured out there is water on moon, but it was like a hydroxyl kind of scenario. They were not absolutely certain, but Chandrayaan 1 had an impactor on it. Basically, it went to the orbit and then they fired a projectile, and that projectile created a plume. That plume confirmed it, okay, there is definitely water. So we went to like, okay, 90% certainty to absolute certainty, like, okay, there is water. So this mission is continuing on that tradition. So this mission is primary focus is like, where is that water and how much it is. Basically, is there 1 ton of it or 10 trillion ton of it? We want to figure out how much. Now to achieve this goal, basically figuring out where the water is and how much is, we trying to basically land it as close to as south pole of the lunar system, basically as close to pole as we can possibly do. However, there are certain limitations given the fact the solar cycle of moon is different from Earth has like 24-hour cycle, so you have 12-hour day and 12-hour night. Basically on moon it's very different. So moon, you have 15 days of day, 15 days of night. Now that creates a problem. That means it has to go on hibernation for 15 days. That cannot be done, because if you put something like, no matter what kind of insulation you use, over time it starts to cool down. See, only way other rovers and other systems, either they had very big batteries or radiation heater elements to make sure they like a radioactive heating elements to make sure that it does not freeze to death. ISRO does not have the clearance for that, so that is why they have only 15 days of life. Because even though the circuits are there, the electronics, everything is tested in such a way that hopefully that if, let's say, it goes through 15 days of work and then it shuts down once it detects a low power output on the solar cell, it's supposed to go to shut down and then has the ability to wake up on the next day, basically after 15 days of silence. But again, they are not expecting it to work because the cold temperature can go very low, and we are going closer to the pole where it's so cold that it's like one of the coldest temperature on the solar system itself. And not to mention we don't have radioactive heating elements. So those things combined is like kind of a tricky situation. Now we could be surprised, we may find out, hey, it keeps working for like months to years, but again, the main goal is 15 days of life out of this. However, the orbiter is supposed to keep working for 1 year at least. So why we are doing it? Okay, that's the mission, that's the project. What we are supposed to learn from it, basically in terms of scientific goals and all that. Basically, this is what we classify as technology demonstration mission, because India is slowly building its space capability, and ISRO provides launch services to many other countries, many other small countries. They go through India to launch their satellites. So demonstrating technology is a really good way to acquire assets, basically. So technology demonstration with Chandrayaan 1 was that, Mangalyaan was that. Now Chandrayaan 2, if you can figure out basically landing ability on moon, that will be a really good technological demonstration. And even NASA also does this. Like, you're not supposed to send your astronaut on your first mission. You're supposed to do demo mission brick by brick, and then you are like, okay, now I'm finally ready. So this is why we are doing it. Now, second, soft landing on moon sounds supposed to be easy because it does not have an atmosphere, so you don't need heat shield. It has very low gravity, so it's not gonna be hitting it very far. But it's very complicated. Anything that has like to deal with rocket science is complicated. So soft landing on moon is ludicrously difficult. So let's say we figured it out. Let's say we finally landed. What our equipment will do, basically, once the rover is on the surface, it will have X-ray spectroscopy, and there are other options also: laser spectroscopy and X-ray spectroscopy. So that's the main target of it. Basically, it's gonna, wherever it's gonna go, it's gonna do spectroscopy. Now that's the rover part. Then you have the lander, basically the static home front. Now that has a seismometer, basically earthquake detector. Now you're like, why the heck we need earthquake detector? Now primary target for that is because we have recently discovered that moon is cooling. Basically, moon no longer has a molten core, so it does not have internal heating, and the surface area is not enough that the sun is bombarding enough energy into it, so it's cooling. Now again, we used to think, of course, it's going to take few million years and it will have no apparent change, but it started to show apparent change. It's starting to shrink and it's starting to create crack lines, basically fault line that is on the surface. So we want to analyze that much more effectively. So we have to have a seismometer there. So that's one of the payloads. There is thermal payload, so basically temperature fluctuation and plasma availability and all that. So there are a lot of scientific missions also in this. Then the orbiter, the thing that will remain there the longest, it is the basically command and control comm centers. Basically, it's supposed to work because neither the rover nor the lander can directly communicate to Earth with a high enough bandwidth. Rover flat out can't, and lander is like, yeah, it's not meant to do that. We can bypass it, we can force it, but it's not meant for that. So every signal, the rover, the vehicle that is moving, that will send the signal to the lander. Lander will send the signal to the orbiter. Orbital will send the signal to Deep Space Network of India. So that's the pipeline. So orbiter must work. Now orbiter also has radar, because let's say you landed on a place and there is not enough water. It's the rover is not like, it's gonna keep exploring for 500 kilometers or something like that. So if that does not turn out, or even if that turns out, the rover, the orbiter itself has a lot of fancy radar and high resolution camera. Using that, we can map out basically subterranean water sources. Basically, is there water ice trapped within the lunar dust? Because you have to understand, let's say some comet landed and there is ice there, but it will be dusted over the course of 100 years or million years, whatever have you. So in those sort of scenarios, having a radar really helpful. So these are the three primary goals. Basically, use spectroscope, use a seismometer and thermal temperatures, and then using radar, figure out how much water is there and where it is. Now NASA has also donated one of the basically retroreflector. The laser retroreflector NASA is giving almost to anybody who's going to the moon, because this retroreflector is very simple device. It's just nothing fancy, no electronics in it. It's just you're supposed to fire laser at it and it will bounce back the laser. The Israeli Beresheet mission also had this. So the idea is that NASA wants to scatter these puppy around everywhere, basically everywhere they want to, and then they figure out the velocity of the moon, distance of the moon, and with a very high precision, because Apollo mission also did that. Apollo mission also had one of them, but the more you have, the more precise the data would be. So for this reason, NASA is giving, like, anybody, you're going to the moon, please carry this with for me, because it's not that big or heavy. So it is also being done. So we have a lot of instruments and most of them are made in India. How we are actually going there, that's basically our heavy lift rocket, which is geosynchronous satellite launch vehicle Mark 3. We had GSLV, it's just Mark 3 is the first time we are pushing Mark 3 to the maximum. Now the landing supposed to happen on 7 September 2019. Now that is very critical, because if we land, let's say 1 or 2 days most, it will directly take away from solar power. So we have to make sure we land at the beginning of the lunar day. If not, if let's say for some reason that does not turn out, or orbit because we are doing orbit raising maneuvers, if that does not work out correctly, we have to delay it to maybe like next another 15 days, because we must land at the beginning of the day. If we land at the beginning of the day, we get 15 days of work time. If we land, let's say, at the end of the day for some reason, let's say some fault occurs or something, orbit derailing does not work as expected, and we end up landing in the 7th day, you have only 7 days of work left. So it is very critical that we land exactly on 7th September, like plus minus 1 day, okay, it's just, but it will shrink directly from our mission capabilities. Now the rocket, even though it's powerful and it is heavy lift, it's not that powerful. So what we are doing is basically going into elliptical orbit and raising orbit maneuvers, basically going there. So So that's how we are raising the orbiter. So he's supposed to do that 5 times, and on the 6th time it will do trans-lunar injection burn, basically directly go to the lunar surface. So that's how we are gonna actually do that. And landing site is already selected, because you have to understand that if you look at the lunar basically map, you will find most of the things are happening in this band. There's like this band, everything is landing inside this. Nobody actually tries to land on the pole. This is the first time somebody is doing that, and India has 2 sites selected. One is primary, another is secondary, let's say, because the orbiter has high resolution cameras and high resolution specifically equipment that is built for testing out whether we can actually land there or not. If it, let's say, finds out there is a fault with the first one, it can go to the secondary. We have done best we can do from all the resources available, but again, just in case, let's say, that does not work out, it gives us a fail-safe place to land. So that's how it's supposed to work. So what is the importance of this for Indian people? Basically, the impact of it on India itself. You have to understand, Chandrayaan-1 worked flawlessly as it's supposed to do, but it ended in 2009. Like just after that it ended, India started to work on Chandrayaan-2, but it has been delayed very significantly, simply because of the Russian thing, and also GSLV development also took a hit. So the delay is also a very big problem. Now India was very close to becoming 3rd nation to land on moon, not 4th, 3rd, because you have to understand the original timeline was January 2013. If India has, let's say, even delayed by 2-3 months, the Chinese mission that actually soft landed on moon, that was on December 2013. So we had enough buffer, like almost half-year buffer, where we could have completed the mission and become the 3rd nation to land on moon. Now Israel also made it. Now here's the odd part about that. Israel did not do this. Israel had a private individual who created a private company using Israel's name, but legally everything was legal here. It's just they directly used SpaceX. So SpaceX was doing a geostationary launch mission for another country, and they are like, okay, we're gonna do this as secondary payload. So geostationary satellite was the main mission. They just piggybacked on that, and they almost came very close to actually landing, because the lunar burn happened. They went in the lunar, they did the orbiting, and during descent they failed. So you have to understand, India became very close to become the 5th nation to go to moon. So this was like a kind of embarrassing, because this is not a big company, not even a like basically a space corporation from a nation. It's just like somebody tried to do this, and it was originally meant for Google X Prize. So you have to understand that if this has happened before India ISRO does that, that would have been like a kind of a messy situation. Let's just say put that. Now remove the prestige side out of it. Let's remove the prestige out. Is there a logical scientific reason for this? Yes, because GSLV Mark III is the foundational core of our Gaganyaan mission. Gaganyaan is basically India's human basically space program. So you have to understand, we have to test the GSLV Mark III to its maximum, so we can confidently use our Gaganyaan mission. And Gaganyaan mission is supposed to start testing at 2022. So we are very close to actually having that. So this mission is very important from that standpoint. It's like ISRO needs to know how good the rocket is, like how does it actually work. And every time we do robotics communication and all that, we learn not so much about it. It's that those information is really valuable. If we learn things from Chandrayaan-2, it will directly help Gaganyaan mission itself. So there is an actual reason for this. It's like a building block. We build the rocket, now we push the rocket, now we have like a confidence, okay, does the rocket work, how it's supposed to work, like what are the limits of this. Once we have that, then we are like, okay, we are ready for Gaganyaan. So this is the reason why we want to do that. Again, prestige is awesome. Like if India would have become the 3rd nation, I would have been really happy, because the 1st and 2nd nation, they did almost neck to neck from basically USA and USSR. They were neck to neck, and USSR is no longer a country. So you have to understand, like that would have been a big deal if India would have become 3rd, and we came so close, so close. But again, China was like almost racing us neck to neck, and they had backup on top of backup on top of backup. So there was a good chance that we may not have been, it would have been a close call. But again, 4th position, once that started to become challenging, the prestige wise, that's a very big if. But again, even if you remove prestige, the fact that we have to test the rocket, before we can say go ahead with Gaganyaan. So it is important for us. So this was my presentation on Chandrayaan-2. I hope you liked it, learn from it. In that case, please click the like button. If you didn't like it, didn't learn from it, I would urge you to press dislike. Please press it twice to show me your extra disappointment, and I would urge you to leave a comment, because I reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.